see, we can do a let statement again, where we're going to let the inside term inside here be a. And so we end up with a squared. And if we let the inside term here be b, we end up with b squared. So we end up with a difference of squares when we do this let statement. And I can factor this with a's and b's instead of j's. So when I do that, I end up with a plus b and then a minus b. So we end up with a factored term that looks like this. Okay, and we can then replace the a with the expression that we substituted for. So instead of a, I'm going to use 4j minus 2 plus the b, which we worked out to do 2 plus 4j. So for that section then, the 2's cancel out and we end up with 8j. Okay, so let me just rewrite that, 8j. For this section here, we're going to end up with 4j minus 2 minus 2 plus 4j So what ends up happening here is that the minus 2's can combine to get minus 4. The 4j's cancel out, so we end up with minus 4. Okay, so this factors to negative 32 times j. So that's one way we can do it. An alternative is we can just do the expansion. So we can expand out 4j minus 2 squared. So we end up with 16j squared minus 8j minus 8j, so minus 16j. Negative 2 times negative 2 is plus 2. Minus, we can expand out this. We end up with 4 plus 8j is plus 16j. And then 4j times 4j gives me 16j squared. Okay, some of these terms cancel out. So this is going to be 2 times 2, which is 4. Okay, so we can see a lot of these terms will cancel out. We end up 16j squared minus 16j squared. 4 minus 4 cancel out. And we end up with negative 16j minus 16j, so we end up with negative 32j, and that's our factored form. We have our just the two factors, 32 times j. So that's another way we could have done it. We could have just actually multiplied this all out, and we end up with just a monomial term at the end.